Hi friends, welcome back to an interesting topic, Kepler's laws and properties of ellipse. Kepler's laws are the laws related with planetary motion. It was developed by Johannes Kepler. He was assistant of Danish astronomer Tycho Brahe. Based on Tycho Brahe's observations, Kepler formed three empirical laws on planetary motion. It is known as Kepler's laws. What is first law of Kepler? Also known as law of elliptical orbit. The statement is each planet moves in an elliptical orbit with Sun at one of its foci. That is, if this is the orbit of the planet like Earth, then the Sun will be at one of its focus, that is at this focus or at this focus. So we have found equation of motion for the planet with energy E as r is equal to r0 by 1 minus epsilon cos theta. We know that where this epsilon is the eccentricity, which is in between 0 and 1 for the ellipse, where this r0 is L square by mu c, where this L is the angular momentum, mu is the reduced mass of the system, and c is equal to the g capital M and small m. And this eccentricity is given by root of 1 plus 2 E L square by mu c square. So this equation represents an ellipse only when this eccentricity is in between 0 and 1. That is, this eccentricity becomes less than 0 and less than 1 and greater than 0 when this value is a negative value, that is less than 0, and also the magnitude of this one is less than 1. For example, this is minus 0.5, then the value inside the square root will be 1 minus 0.5, that is plus 0.5, like that. So that for this condition, this E must be less than this one. So for planets, using the orbit equation, R max equal to, using this equation, this becomes a maximum value when this cos theta becomes 1. That is R max equal to R0 by 1 minus E. And this becomes a minimum value when this denominator becomes maximum, that is 1 plus epsilon, or when cos theta becomes minus 1, that is R minimum is equal to this R0 by 1 plus epsilon. So that this epsilon is obtained like this from these two equations. Dividing and then subtracting and rearranging, we get this eccentricity epsilon r max minus r minimum divided by the r max minus r minimum. So this eccentricity, using this r max and r minimum, the eccentricity for various planets are calculated like this. For almost all planets, the value is very, very small, very near to the 0. For Earth it is 0.017. So that the epsilon is equal to 0, means eccentricity is equal to 0 represents a circle. Means for Earth, this path, this orbit is very near to the circle, but it is still an ellipse, but very near to the circle. So what is second law, also known as law of equal areas? Again, the statement is like this: the radius vector drawn from sun to a planet sweeps out equal areas in equal times. That is, a radial vector drawn from sun to the planet sweeps out equal areas, these areas in equal time. For a larger distance between the planet and sun, the area is like this, and for a smaller distance like this area is like this. So it sweeps out equal areas in equal times. For a two-body system with central force, we know that the torque is toss equal to, which is the dl by dt, which is equal to r cross f, where f is the central force. So r is along the r direction, and f of r is also directed along the r, so that both are along the same direction, so the cross product becomes 0. So this torque is 0, means this dl by dt is 0, that is this L is a constant, that is the angular momentum L c equal to r cross p is a constant, that is the constant both in magnitude and direction. So for small values of delta theta, for small values of this theta, the area delta A is approximately equal to the area of the triangle, like this, area of this triangle with base r plus delta A and altitude r delta theta, with r delta theta and r plus delta r. That is, this area is given by 1 by 2 into this r plus delta r into this r delta theta, which is equal to this one, but we know that this will be very smaller compared to this term. This is delta r into delta theta, so that this is neglected. So this delta A, the area swept, is equal to 1 by 2 r square delta theta. So that the rate of area swept will be this delta A divided by delta t. For a smaller time, when delta t tend to 0, this becomes the differential dA by dt. That is, dA by dt is equal to limit delta t tend to 0, this divided by delta t plus this divided by delta t, where this term is neglected, so that this term remains, that is 1 by 2 r square d theta by dt. But we know that mu r square d theta by dt, or mu r square omega, is L. Therefore, this is equal to L by 2 mu, which is a constant. We know that this L is a constant. We found from this equation L is a constant, and the mu is the reduced mass, which is again another constant, so that this L by 2 mu will be another constant. That is, this dA by dt is a constant, or the radius vector drawn from sun to a planet sweeps out equal areas in equal times. Now the third law, or law of periods, it states as the square of the period of revolution t of a planet about the Sun is proportional to the cube of the semi-major axis of the elliptical orbit. That is, t square is proportional to a cube. We know that the length of the major axis, semi-major axis, is 2a is equal to r minimum plus r maximum. We found the r minimum is r0 by 1 plus epsilon, and this r maximum is r0 by 1 minus epsilon. So that this is equal to this 2a is equal to 2r0 by 1 minus epsilon square, or this a is equal to r0 by 1 minus epsilon square. And also we can show that the semi-minor axis b is equal to r0 by root of 1 minus epsilon square. We also know that the area of any ellipse is equal to pi AB, where A is the semi-major axis and B is the semi-minor axis, which is equal to L by 2 mu into T. From this second law, that is the area law, that is dA by dt is equal to L by 2 mu, we can integrate this equation, this dA and this into dt will provide this one. This dA gives A and this integral dt gives capital T. That is this one. The area of the ellipse is equal to pi AB is equal to L into T by 2 mu. Now squaring this one both sides, that is, and rearranging for t square, it is obtained as t square is equal to this 2 square mu square by L square is taken to the other side, that is here 2 mu divided by L, then this pi a b all square, that is 4 mu square pi square a square b square divided by L square. But we know this b square and this a square is related like this. You can see from these two equations, this b square is equal to r0 into a. This b square is equal to r0 into a, so that we can replace this b square by r0 into a. And also we know that this r0 is again provided by the L square by mu capital G, capital M and small m, so that it becomes like this. For 1 mu gets cancelled, then pi square a cube divided by G capital M small m. This L square is also gets cancelled, where this 4 is a constant, mu is a constant, pi is a constant, capital G is a constant, capital M is a constant, this M is a constant, means all these are constants, so that this t square is proportional to this a cube, that is t square is proportional to a cube. So this is the third law, or law of periods. The square of the period of the revolution is proportional to cube of the semi-major axis of the elliptical orbit. Now we will see some important properties of ellipse. For a general conical section, the equation of the ellipse, the equation of the general conical section is provided like this. R is equal to r0 by 1 minus epsilon cos theta. For ellipse, this epsilon should be in between this 0 and 1. You can see that here Cutting the cone like this provides this ellipse. When like this it becomes parabola, when like this it becomes an hyperbola. So in terms of Cartesian coordinates, the elliptical equation is like this: x squared by a square plus y square by b square is equal to 1. And few important relations connected with ellipse. Area, we also mentioned the area is pi into a into b, where this a is the semi-major axis and b is the semi-minor axis. So this is a, this is the semi-major axis and this is the semi-minor axis. And the R maximum we also again mentioned, when cos theta is equal to 1, when cos theta is equal to 1, this R becomes R maximum, that is R0 by 1 minus epsilon. This R, this is the R. So this R becomes maximum when cos theta becomes 1 or this theta becomes 0. And this R becomes minimum when cos theta becomes minus 1. That is when theta is equal to pi. When theta is equal to pi, like this. When theta is equal to pi, that is 180 degree, this R becomes R minimum, which is equal to R0 by 1 plus epsilon. Thank you. Thank you for watching.